Thank you for joining this lesson. We're going to study the thin lenses from 4 physics. An object is placed 30 centimeters in front of a thin converging lens of focal length 20 centimeters. The setup is represented in the figure below. So this figure is showing us a converging lens, which is otherwise called the convex lens. We have the object placed 30 centimeters in front of this converging lens, and the converging lens has a focal length of 20. So focal length is f, 20 centimeters. Let us see the questions thereafter. On the same figure, construct a ray diagram to locate the position of the image. Therefore, we're going to locate all the responsible rays for the formation of an image. We should know that there are 3 very key rays in the formation of an image by thin lenses. And that is, if a ray is from the tip of the object through the optical center, which is this one, through the optical center of the lens, that ray passes undeviated. Therefore, if a ray is from the tip, be very accurate, from the tip through the optical center, such a ray will just pass undeviated. So once it reaches the optical center, it passes undeviated. We can do another ray. If a ray is through F to the lens, from the tip through F, which is 20 centimeters, this is F. So from this point through F to the lens, let me try to elongate the lens. Once it reaches the lens, this ray now, remember a ray should be having an arrow to show its direction. This ray is refracted close and parallel to the principal axis. Therefore, this is the principal axis. The ray becomes parallel to the principal axis. Therefore, I'm just supposed to give a very straight line. A very straight line. So that is how the ray behaves. We can have a third ray just to confirm, but 2 rays are usually enough. If a ray is close and parallel to principal axis from the tip of the object, close and parallel to principal axis, this ray gets refracted through F. Therefore, the ray will pass through F. The ray is going to pass through F. Therefore, the ray is again confirming to be converging at the same point where the other 2 rays had converged. Therefore, 2 of these 3 are enough to make us conclude about the image, position and size and all that. So now that is how the image and where it is going to be. So we can see the image is enlarged, or rather magnified. The image is formed at a distance on the other side. If we assume that this one has been drawn to scale, then we will have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 6 divisions for 10 units. Then we have 1, 2, 3 divisions. That means with another 6 divisions, this could have been our 40. So this means this image is being formed at 35 centimeters because it is in between 40 and 30. Therefore, what we call the image distance, otherwise abbreviated as V, equals to 35 centimeters, whereas the object distance abbreviated as small letter u equals to 30 centimeters. Therefore, for number 2, to determine what we call the linear magnification, we're going to have V out of U. Therefore, we're going to have V, which is equal to 35 divided by 30. And this will take us to 1.17. This is the linear magnification. Let me proceed with the question. An object 6 centimeters tall is placed 40 centimeters from a convex lens of focal length 50 centimeters. Find the position of the image. Here, we're going to use what we call the Lense formula, which says that 1 out of F equals to 1 out of V plus 1 out of U. In this case, F is the focal length, and according to the instructions, this is 50 centimeters. V is the image distance, where the image gets formed, and that one is unknown. And something else we know is it is placed 40 centimeters from a lens. So we know U is 40 centimeters. So we got F, we got U, but we don't have V. We can substitute to the formula. 1 out of 50 equals to 1 out of V plus 1 out of U, which is 40. So to remain with 1 out of V, we need to take 1 out of 50 minus 1 out of 40. 1 out of 50 minus 1 out of 40. And this gives me negative 1 out of 200. This means we're going to have V translating to negative 200. This means that we're going to form a virtual image. The negative signs will mean that now the image is going to be virtual. It is virtual, or rather rays which are not real, that will converge to give us an image 200 centimeters on the same side as the object. So this is going to happen on the same side where the object is, negative 200. To continue, we are taught to state 2 differences between the human eye and the camera. A difference between the human eye and the camera is that the focal length of the eye is fixed, while that of a camera can be varied. This one can be varied. Again, about the camera, the image distance. Image distance of the camera is fixed, is variable, sorry. For the camera, we can adjust the length and hence affect where the image gets formed. It's variable, while that of the human eye is fixed. That of the human eye is fixed. Now, for a human eye, we can form multiple images. Remember, we just wanted two differences, but I can add a third one, that for the human eye, at the same time, we can form multiples of images, but for a camera, it's only one image that can be formed at a particular time. So that is the few differences we have between the human eye and the camera. Thank you for following. Subscribe and share.